Hello friends, we are going to study superposition theorem. Coming to the topic superposition theorem. In any linear bilateral network consists of number of energy sources. The effect produced in any element when all the elements club together at a time is equal to sum of effect produced in the same element when each source is considered individually. We can understand this with the help of example. This is the load resistor RL is equal to 5 ohm, and this is your 1 ohm, this is 1 ohm, this is your voltage source 5 volt, this is your current source 2 ampere. Then the value of current I naught will be what? When all the sources act at a time, then the value of I naught is, let us assume, your 5 ampere. And when we will take the circuits individually, means once we will be taking the 5 volt resistance and here we will calculate the I dash, and once if we will take the 2 ampere and then we will calculate here the value of I dash, then the algebraic sum of these two currents taken individually will be equal to this 5 ampere. It means we can say the effect produced in any element when all the sources at a time is equal to 5 ampere is equal to sum of effects produced in the same element when each sources is considered individually. Let us calculate the value of I and verify the superposition theorem. Now first of all, I will calculate this value of I when all the elements act together. Simply I can apply any method. So I am applying supernode analysis. Let us assume this is I1, this is I2, all the currents are going outward, so we can write I1 plus I2 plus I is equal to 0. The value of I1 we can write, let us assume this is your V0, V0 minus 10 upon 1 plus I2. We can take the value of I2 is equal to minus 2 ampere because this I2 is in opposition with 2 ampere. So the I2 value will be equal to minus 2 plus I value will be given as V0 upon 2 is equal to 0. Multiplying by 2, 2V0 minus 20 minus 4 plus V0 is equal to 0. 3V0 is equal to 24. So the value of V0 is equal to 24 by 3, that is 8 volt. And the value of I will be V0 by 2, that is coming to be 8 by 2, and that is your 4 ampere. This we response calculated at a time, and now we will take individual element and we will verify the superposition theorem. When we will find out the response individually, first of all we are taking 10 volt. If we are taking one source at a time, then all other sources will be cut out from the circuit. It means if the voltage sources will be there, then it would be short circuit, and if the current source will be there, then that would be open circuit. And if we are taking 10 volt, means first sub circuit, then we have to cut out from this circuit plus minus 10 volt, this is 1 ohm, and this is 2 ohm, and this will be your I dash. This is your 3 ohm, and this will be your open circuited because this is current source. And now we can calculate the I dash value from here. I dash will be directly 10 upon 3 ampere. This is the first sub circuit while we were taking 10 volt. Now the second sub circuit. Taking 2 ampere. If we will be taking 2 ampere, then this voltage source will be short circuited. Short circuited. This 1 ohm. This is 2 ohm. This is 3 ohm, and this we have considered 2 ampere at this time. And now we have to calculate the value of I double dash. Easily we can calculate with the help of current division rule. The value of I double dash will be equal to 1 upon 1 plus 2 into 2. So the value of I double dash will 2 upon 3. And all the currents are in down. I double dash is equal to 2 by 3 ampere, and we can see all the currents, whether I dash or I double dash we have calculated, it is in downward direction. So we have to keep the algebraic sum. So the total I will be equal to I dash plus I double dash, and that is coming to be 10 by 3 plus 2 by 3, that is 12 by 3, and that is equal to 4 ampere. By the help of nodal analysis, we just found out the value of I was 4, and when we considered each source individually and while taking the algebraic sum, we are getting the 4 ampere. It means the superposition theorem is verified. Let us assume we have one circuit in which both independent and dependent sources are present. Then how many number of sub-circuit we have to design? If we are considering this circuit, then we have 3 sources. First 2 ampere independent source, second 5 volt independent source, and this 3V0 voltage source, and that is dependent source. But we do not need to write the sub circuit for your dependent sources. We only write. One question has also asked in examination the number of sub-circuits to be solved while applying superposition theorem is, while I is the number of independent sources and D is the number of dependent sources. So which will be the correct answer? 1, 2, 3 and 4. We know that we can only write sub-circuit for your independent voltage or current sources. So the option will be your I only. Thank you.